Now we'll start with the another problem, and that would be the last problem of print number 1. So first of all, I'll be writing a problem that's and the problem is to Indian standard angle section 100 by 100 by 10 mm angle is to be welded in shop to 12 mm gusset plate. The angle carries an ultimate pull of 300 kN. Applied along its centroidal axis which is 28.4 mm. From the back of the angle. Now there are two parts. The first part is to determine the length of the side fillet weld required at the heel and toe of the angle. At the heel and toe of the angle, and then there is the another part. Determine the length of side fillet weld if the transverse fillet weld is added at the end of the angle. So that's the problem. That's Indian standard angle section is given, and it is to be welded in shop to 12 mm gusset plate, and this angle carries ultimate pull of 300 kN that applies it along its centroidal axis, and the centroidal axis is from 28.4 mm from the back of the angle. So this is what it's given, and you need to determine the two parts. The first part is to determine the length of the side fillet weld, which is required at the heel and toe of the angle, and there is length of the side fillet weld. That is the second part. The transverse fillet weld is added at the end of the angle. So we'll be solving these two parts in this problem. So we'll go to the solution of the first part. So for part A, weld along the length. So first of all, we will draw the diagram through which you will be understand better. Now this P is already given, that pull is 300 kilonewton. And then we do have, well, basically this is ISA 100, 110, and we have this 12 mm gusset plate. And we can consider, suppose, this P1, P2 as the resisting forces, and that may be at the heel and toe of the angle section. So let us have this force. This is P1 and this is P2, and we'll be calculating this P1 and P2 forces, and once we calculate that, depend upon it, we'll be assuming certain weld section, and from that weld section we'll be getting actually exact how much length will be required at the heel and toe. So it is altogether depend upon what is the force P1 and P2. Also in the problem it is mentioned that this force is at the distance of 28.4 mm. So now we will move towards the part, and let us consider, say, we can take the moment about point P2, and therefore about P2, so we'll be getting P1 so this P1 since this is total is 100 mm section, so P1 multiplied by 100 would be here and let's say total P would be multiplying 100 as the total minus 28.4. So this is this distance and therefore we will get P1 multiplied by 100, which is equals to P is already given, that is 300 multiplied by 100 minus 28.4. So from this we will get P1 is equal to 214.8 kilonewton. So that is the P1 force, and to get the P2 force we have P2 will be equals to definitely capital P minus P1 because they are the resisting forces. So therefore capital P is 300 minus 214.8, so we'll have this 85.5 kilonewton. So that's the P1 and P2 forces. Now we'll be going through size of the weld required. So now we have a maximum size of the weld. So maximum size of the weld is equal to 3/4 of the thickness. So this can be from the clause 10.5.8.2, page number 79. Which we have already gone through in the earlier steps. So this is 10.5.8.2. The fillet weld is applied to the rounded toe of the rolled section. The specified size of the weld should generally not exceed 3/4 the thickness of the section at the toe. So this is what will be requiring. So 3/4 of the T, so we got here 3/4 multiplied by 10 mm is the thickness of the angle section. So if we calculate this, you will get it around 7.5 mm. So this is the maximum size, and we can adopt, let us say, lesser than that, maybe 6 mm. And then we will be requiring throat thickness. So for the throat thickness, again we do have the formula on the page number 78. So this is throat thickness shall not be less than 3 mm and shall generally not exceed 0.7 T. Right. So let us adopt 6 mm weld. Okay, and now as I have shown you, so we need to calculate throat thickness, that is denoted by TT, and as you have seen, this is 0.707 more accurate of the we are getting 6 mm weld, so multiplied by 6, So this is going to be around 4.24 mm. And now we can also calculate the strength of the weld. So strength of the weld, so we do have this, we can even write down here. This is again from clause 10.5.7.1.1, page 79. We do have the strength of the weld, which is denoted by FWD. Therefore FWD, which is equals to okay, let's show you the same thing. So this is FWD, design strength of the weld. FWD, which is equals to FWN by gamma MW. Partial safety factor FU by root 3. FU, that is the smaller of the ultimate stress of the weld, and then this is the partial safety factor. So we can write down this, which is equals to Wn divided by gamma MW, and this is to be multiplied by throat thickness. So if we just multiply it by the throat thickness, FWN, this is FU by root 3 into TT, and this is 1 by gamma MW. So we got here FU, that is 410 by root 3 multiplied by TT, we got 4.24 multiplied by, this is the gamma MW, which we already seen in the earlier video, 1.25 from the table number 5, page number 30. So if you solve this, you will get it around 803.1 Newton per mm. Okay, so this is what we will get it, FWD, that is the strength. Now once you got the strength, we can get the effective length. So now effective length, that is, let us say it is denoted by L1 and that is equals to P1, whatever we got earlier, and divided by strength of the weld. So you got here P1, which is equals to 214.8 divided by this is to be multiplied by 10⁻³ to make it in terms of Newton. So 214.8 divided by 803.1. So here you will get it around the length. This you can make it around 270 mm, and similarly we can calculate L2 will be equals to here P2 divided by FWD. So here P2 is equals to 85.5 converted into Newton and divided by 803.1. So you will get it around 110 mm. So this is how we will get the length 270 mm which is at the heel, and then 110 mm which is at the toe. So that's the length to be. So if we just draw it again, let us have this. So that's it. You need to show how much length of the weld required. So this one is your 110 mm and this one is your 270 mm. So that's 100 by 100 by 10. So this is how you will get the fillet weld at the heel and toe of the angle. So the second part of the problem we will solve it in the next video.